So we will start today to do some dynamic in our Canvas tutorial lesson 2. So we have to build at least one sprite that will be collide with boundaries. So first of all, so we just put here the comment lesson 2. We have to replace layout from the set content view because we are not going to use layout for the Canvas game. So what we can do, we can click on the name of the layout, right click, and choose here delete, and uncheck save delete because we know what we're doing. Remove this line and change set content view to the game view. The same what we did before. We will write new game view and the constructor this. So we'll create a game view in a moment. I would like also to request a window feature without title. It will give us more space in the application. So I'll write here request window feature. It will be window dot feature no title. So in this case, we'll be guaranteed that title will be eliminated, and then we'll stay here, wait for a second, and create class game view. So class game view will be created in the same package. The first change we will make, we will change view to the surface view, because this way we'll have a more direct level to work in the canvas. And in the constructor, we basically use a context. I delete this, click here, wait for this, and create constructor matching super. And I will choose constructor with the context parameter. The next we'll create two private variables. One variable will be actually bitmap we would like to display, bmp, alt enter to import the library. And second variable will be private surface holder. So we spoke about the role of surface holder in the tutorial number 1. So right now we're going to initialize holder by calling method get holder. So this basically repeats step from the previous tutorial. Right now we're going to add a callback method to the holder, holder.add callback, and inside will be a surface holder callback static variable call. And when I select this, I will get all 3 methods added to the program. The next step, I will attach a bitmap to the game view. So I will, first of all, I would like to copy paste bitmap to the drawable folder. So this is the bitmap image that I would like to bring. So that should be drag and drop in drawable. So because it doesn't work direct transfer like this drag and drop. So what I will do, right click, so I'll copy and paste the image to the drawable using paste. But I will go to the upper level drawable, not drawable version 24. Press OK. So let's connect this image to the BMP variable. So we did it in the previous tutorial. We have to use bitmap factory dot decode resource using get resources comma r dot drawable dot green. So green, actually this is the name of the image that I just copy pasted to the drawable folder. Next we will override protected on draw method. So make sure that we go outside the constructor and override one more method which has a name protected void on draw. And on draw would have only one parameter, canvas. So we added protected void on draw with the canvas variable. So why it's important to use override notation? To make sure that we're using correct method from the specific superclass from the surface view class. And we will do the same what we did before in onDraw. So we will draw the particular bitmap. But in this case, we will make some changes. We will check if the canvas is not null. So I will explain you later why we need to do it, because it will be important to draw only when canvas is available. So let's do the draw color as we did before. Color dot, for example, blue. We will do canvas dot draw bitmap, and arguments will be BMP, and let's put coordinates x1 and y1. Since we're going to change the coordinates later, it's a good idea to make them dynamic, and then create a private int x1 and y1 on the level of the variable. So we'll just say here, create here sprite data, and create here private int x1, just assign to 10, and do the same for y1. Now we're going to add game thread to the game. I would like to remind you that game thread will allow us to run onDraw method only when this thread is active. So we will create a file, separate Java file, the extend thread. So let's go back to the program and create here one more private variable, game thread with similar name. And in constructor, after super somewhere, we have to initialize a game thread variable in the same way calling constructor. Since we don't have this class, it might be important to create class before, but we will create class in a moment. Just don't forget to include this parameter as to reflect the context, and don't misspell this true name of the class. I actually did it, I misspelled it, so please be careful with this. And then when you stay here, wait for this prompt and create class game thread. So remember, the class game thread will be extend thread, and that's what we require to do. So let's start with the game thread method, game thread class, to including all variable and method. So the first will be game variable, which has a name view. We need a private boolean flag that will be reflect when thread running or not. So by default, thread is not running at the very beginning. And we'll create constructor game thread that has a game view. So this constructor basically accepts view as one parameter and is assigned to the current view. One more method we need to set thread running whenever we need it. So we will create set running with boolean run. And basically what we assign here, running to run. So we're done with the classical method with constructor and method to control running thread. Now we have to add run method. It might be a little bit complicated. Maybe we need to try to implement it. So go here and so we'll choose code, override method, and for the thread we have to override run. So please check run, copy Java doc, and you will receive this method just before set running. So maybe it's a good idea to do some kind of changes in the order, will be easier for us. And right now we want to implement this method inside. Check first of all if flag is true, flag running is true. So once it's true, we will run the thread. So while running, we will create a canvas variable, local canvas variable. So Alt Enter. Then we will do the try block. We will try to do synchronization inside canvas. First of all, we will using get holder we log the canvas. Get holder dot log canvas. Then we need to do the drawing and unlock the canvas. So it's a good idea to use synchronization in this case, synchronized procedure for this process. View dot get holder and after this inside once we get this view we will call onDraw method for the current view dot onDraw based on C. And finally we have to do the check if C is not null, we will unlock the canvas like we did in previous class. So we'll use get holder dot unlock canvas and post with C. Alright, so probably we're done with this right now, right? So I guess we have to answer this question. So finally with our try. So since we didn't close one more brackets probably, right? Yeah. This is a problem with draw could be eliminated when we can replace call with draw. That's also possible and eliminate this problem. One of the things, just collect all pieces together and we're done with this method. Just make sure we have 1, 2, 3, 4, 5 here, right? and yeah, looks okay. Class name expected. So maybe I have some kind of disbalance here. New holder here. Final is here. So while running is here. They will be run. I guess I have one redundant. Yeah, I had one redundant. So right now the class is closed. Okay, so we're done with the game thread class in this moment. After this, we're moving back to game view, and we have to modify surface created based on the game thread. So we're using game thread dot set running to true. So we want to start games to run as soon as surface we created. And game thread dot start will make the current thread runnable. Basically, the thread will be start will be called the method run. And we have to write when we what we have to do when surface destroyed. So when we destroy the surface, so we first of all we create the variable to destroy the loop, to construct the loop and destroy the thread. So game thread thread dot set running will be back to false, and basically we need some procedure to disconnect thread, make it not active. So we will try a couple of things inside. We first of all we try game thread to join. So the join method will be waits for this thread to complete. So basically what is required. And once we achieve this, we can stop the loop, convert into false. So with the error here, yeah, unhandled exception. Do we have any help with this? Add catch. That would be cool. Interrupt exception. Yeah. Yeah, we have a lot of stuff here. I guess it should be closed. Probably one brace was redundant. So it was a class game view, and right now we will run the program. And right now it's a success. The image is right now displayed in the left upper corner. So this was a short step we have to accomplish in order to make the image displayed using game thread. And finally, we would like to bring some dynamics in spread behavior. We want spread to change in XY coordinates, and when it reaches boundaries, just go to the opposite direction. So let's open GameView class and add some more properties to the sprite data. So we will add private int x speed, and then write private int y speed. And we also need sprite width and height. Will be private int sprite width. Let's make something default. As usually, write private int sprite height. So yeah, maybe some also by default some speed. We can always comment back and change it if you would like. So having this, we would like to estimate what is the size of the sprite. So somewhere here, after receiving BMP, we can assign variable sprite height, result BMP dot get height. Yeah, just misspelling here. And I want also to do the same for the width. Right now, based on this new data, sprite width height, we're going to change on draw method. So we would like to check border collision left right. So yeah, let's start with this. Check border collision left right. So how we would like to check it? We would like to check if x1 variable less than 0, so we will not go into negative territory, or if the x, y, and coordinate plus sprite width will be greater than canvas width. So canvas width, this is actually the size for the canvas, and this will be one condition. So if this condition is true, x speed multiplied by -1. So what's happening in this case? We just want to go to the opposite direction if one of this condition is true. Just we'll put it here, redundant brackets. So the next we will check border condition top bottom. Okay, so we will check the same but using y1 variable. I'm just copy paste, just want to save some time. So make sure don't make mistake here, because it's very easy to forget to change width to height. And that's also should be height here. And that's gonna be y speed. Okay, so that check we did, but what else we need to do? We have to change xy and y1 coordinates when we call in on the method. So we change x1 and y1 variable. We change in this moment, we change only for plus 10 pixels here, right? So because this is what speed, we can always adjust the speed if you want. And the rest of the method remain the same. Okay, so let's run it. And you see the sprites trying to be first and then disappeared. So it looks like the last border is not working. So where the problem? The problem is really with my copy paste, right? Because I told you that I have to use, we would be extra careful with this, but I did not change x1 to y1. So right now it looks better. I'm sorry for this. So let's try again. Yeah, it's bumping up from other all boundaries right now, and it looks pretty much how we expected. Okay, so we're done with this lesson 2 canvas game. If you have any questions, so please let me know. Thanks.